Okay, hello, this is Chloe Austin, and this is my second ALP. Today we're going to go over how to convert coordinates and equations from rectangular form to polar form and vice versa, and how to write a polar equation of a given polar graph. So first we're going to start with polar coordinates. We want to remember that r equals our radial coordinate, which is the point's distance from the pole. And then we also want to remember our main rules, which are right here. So to start, we're going to convert rectangular to polar. So the first thing we want to do is we want to solve for r. So if you look in the bottom, r equals the square root of x squared plus y squared. So we take our x and we take our y, we put them under a square root, and we square each. And then we end up with 36 squared, or the square root of 36, which is 6. Next, we want to solve for tangent, and tangent is y over x. And when you solve for tangent -1, or we want to solve for theta, but when you solve, you use tangent -1, and you get -30, and then you use our unit circle to find pi over 6, which is the same thing as like 30 degrees, and we're going to find that in quadrant 2, which is where this will be located, and what you would get is 6, 5 pi over 6, and this is our unit circle, and you can see that 5 pi over 6 is our 30-degree angle in quadrant 2. And next we want to find an equivalent polar equation for x squared plus y minus 1 squared equals 1. So the first thing you want to do is solve for y minus 1 squared. And when you do that, you end up with x squared plus y squared minus 2y plus 1 equals 1. And so you're going to move the 1 over, subtract 1 from both sides, and that'll leave you with x squared plus y squared minus 2y equals 0. Then you want to bring the 2y over, so you add 2y to each side, and then finally you want to just convert x squared plus y squared into r, and you want to realize that y over in the corner, you see y equals r sine, so y equals 2 sine theta. Finally, we want to write an equivalent rectangular equation for r equals 3 secant theta, and this one's kind of easy. You just convert 3 secant theta into 3 over cosine theta, and then you multiply and bring cosine over. So r cosine equals 3, and then r cosine, as you can see, equals x, so x equals 3. Now we're going to do polar curves. So there's 3 different types of curves that we're going to go over. There's the limacon, the rose, and the lemniscate. And they're all known for different qualities. So we're going to start, and actually extra facts about the limacon is that if A equals B, it'll be heart-shaped. If A is greater than B, it'll be convex. And if A is less than B, it'll have an inner loop. And then where B minus A equals the distance of the loop, and additionally, A plus B equals outer circle distance. So our first example, we can tell that it's a rose, and we know this because of the form that it's in, the 4 times cosine b theta. And then the effect of the cosine, there will be a petal on the x-axis, and we just know that if b is an odd number, which is the 3, then that is the number of petals. So therefore, we will have 3 petals, and we know that A is the distance, so each petal will be 4 units long, and then my rough graph looks like this. It's not to scale, but you can still see the measurements. Our next example, the type of curve is a limacon, and it's heart-shaped to be exact, and we know this because of the form it's in, the A plus B cosine theta form, and since A equals B, we know it's heart-shaped. The effect of the cosine, it means that the heart will be reflected across the x-axis. Additionally, and that just helps enforce it. And additionally, the intercepts will be on 0, 2 and 0, -2. Those are our y-intercepts. And the length will be 4 units, and we know this because 2 plus 2 equals 4. and this is our rough graph. And we know it's positive because of the plus sign. If it was negative, it would be flipped the other way. Our next final example is r squared equals 4 sine 2 theta. The type of graph is a lemniscate. We know this because of the form it's in. And it's the same thing as writing the square root of 4 sine 2 theta. And that 4 is the same as 2 squared, if you're confused. And we know A is our distance, and since it's sine, it'll be diagonal, and it'll go across. It'll go from the quadrant 1 to quadrant 3. And B equals the number of bow ties. Usually, it's not a lemniscate if it's more than 2, because if it's more than 2, it'll make a rose. So finally, I use all this information to find the distance. The distance is 4. And that's our rough sketch. And it's still 4 units because it goes from, you could think of it as -2 to +2, but it's